Make I dey follow you go wherever you dey go. You been running through my mind, you be using both. My fingertips on your hips, finna make you say yeah.
Hello, thank you for watching this Fundo video. Today I'm going to be teaching transformation. So this video is only covering the subtopic reflection. So these are the other subtopics that you will find under the topic transformations. There's translation, reflection, rotation, enlargement, shear, and stretch. And each subtopic will come in its own video. Let's now begin. The concept of reflection is one that we are so familiar with because we look at ourselves in the mirror on a daily basis. So we are trying to apply the same concept here when we are reflecting points, lines, or shapes on a graph. So that is to say, in this example that we are provided, imagine that you're only given this top half of the graph. So this is the triangle divided across this line, y is equal to minus x. If you're given a mirror and you're told to put you're told to put that mirror across this line, what should you expect to happen? So you have this top half and you have the mirror that is put across this line. So you would expect that a reflection of this top half would be projected, and that would give you this bottom half. So that is to say, you'd expect C to be projected as C complement, and you'd expect C complement to be directly opposite C and also about in the same position as C here. That is to say, our C complement is not too close to the y-axis or it's not too close to the x-axis, because our C to begin with is not too close to the y-axis and it's not too close to the x-axis. So it's somewhere there in the middle in position 3, in position 3-1. So it's somewhere there. And so you can see how it's easy to interpret the reflection of a point. So that is to say, if we were given another point starting here, you'd expect that point to be here. If you were given a different point starting maybe here, you'd expect it to be. So in this example, we were able to reflect a point C across this line, across the line y is equal to minus x. So our point 3, 4 was reflected across the line y minus x, and it gave us the new position, or the new point C complement at the position minus 3, minus 4. And the same concept of reflecting a point on a graph applies to reflecting a shape on a graph. In this example that we are given, we see a blue triangle, a blue shape that is reflected along the line y is equal to 0. This line is also called the line, or it's also called the x-axis. And just a quick reminder, the y-axis is the line x is equal to 0. This can be confusing, so please find a way to cram this because it's essential that you do not mix the two. So this blue triangle has been reflected along the y is equal to 0, or along the x-axis, and it gives us this pink triangle. So just for you to learn a lot from this simple example, you can see the properties of a reflection. That is to say, for example, the size of the triangle or the size of the shape does not change. Since you reflected this triangle, it does not change. So that is to say, when you take a normal mirror and you just look yourself in that mirror, your size does not change, your shape does not change. So these are the same properties that apply here when you are dealing with shapes. So the size does not change, the shape does not change, and also the distance of the original shape is equal to the distance of the new shape from the mirror. So that is to say, from the mirror to this shape, to the blue shape, this distance is equal to the distance from the mirror to the pink shape. As you will notice with many transformation questions, you have to fully describe the transformation that the shape has just undergone. So reflection is very simple. All we need to describe our transformation is the line or the equation of the line on which our shape was reflected on. In other words, what is the line on which you put your mirror? So in this example that we saw, this transformation T is a reflection along the line y is equal to 0. That is how you would describe this transformation. So you have to state that the transformation is a reflection and then give the line of the equation where you put your mirror, or the line of the equation where the shape was reflected. When dealing with transformations, there's usually two ways in which the questions are asked. So sometimes you're given a graph and a shape, and you are told to draw the new shape after a transformation has occurred. So you are given the parameters that go with the question to say, oh, maybe this transformation is going to undergo transformation T using whatever, and then you have to draw the new shape. In other cases, you actually are just given coordinates, and then you are told to find the position of the new coordinate. So this is just numbers. Maybe you're not even given the diagram or the shape for you to understand. In other questions, you're just given the coordinates of a shape or the coordinates of a point, and you have to translate that shape or that point to its new position. And when it comes to dealing with coordinates, we have shortcuts. So this is where matrices come in. So I hope that you're familiar with matrices. If you are not familiar with matrices, you actually have to go back to study matrices. So we won't be teaching matrices in this video because we are just solely focusing on the reflection part. So as you can see in the above example with the green triangles, you can see we are given the coordinates 2, 4, 4, 2, minus 2, 1. And then when that triangle is reflected along the line y is equal to 0, we have our new coordinates. But you notice that there are some similarities amongst these coordinates. So 4, 2 was reflected to 4 minus 2, which is very similar. And then 2, 4 was reflected to position 2 minus 4, which is also very similar. And then minus 2 was reflected to minus 2, 1, oh, minus 2, minus 1. So minus 2, 1 was reflected to minus 2, minus 1. So now that you have seen all these three coordinates being reflected to this new triangle, you can notice the only thing that is changing here is the minus part in the y component of our coordinate. So that is, we had 2, now we have minus 2. We had 4, now we have minus 4. We had 1, now we have minus 1. So there is a formula which you can use as a shortcut for you to calculate the coordinates. So for example, if you're given the coordinates of B, 2, 4, you can use the matrix to calculate the new coordinates, and that is to say you can find 2 minus 4 from using this matrix. So if you multiply your coordinates of B with this matrix, you'll find the new coordinates of B complement the new coordinates of B. So that is 2 minus 4. If you also do the same for C, if you say 4, 2, if you replace 2, 4 with 4, 2, you also find 4 minus 2 using the same method. And if you also do that same thing with the coordinates of A, you will come to the same conclusion. So when you want to reflect a shape or reflect the coordinates of a shape, you can use this matrix that we have provided here, and then you can find the new coordinates. And then when it comes to this other shape that we are seeing on the slide, the red and the blue shape. So this is a pentagon, since it has 5 shapes, just as a quick reminder. Yeah, so we can see our shape A here, or our point A, which had 2, 4, was reflected along the line x is equal to 0 to a new point minus 2, 4. And we also look again and we see 4, 3 was reflected to minus 4, 3. And we see or 0, 2, which is E, was reflected to 0, 2. And then 4, 0 was reflected to minus 4, 0. 2 minus 1 was reflected to minus 2. So in other words, like in short, this red shape, the red pentagon, was reflected along this, and it also has similar coordinates. And in those coordinates, only one thing is changing. In this case, the x component of the coordinates is changing. You can see with 2 we have minus 2, with 4 we have minus 4, with 4 we have minus 4, with 2 we have minus 2. So now you can see how instead of using this matrix, we actually have to use a different matrix for us to be able to calculate this. So what's causing the difference in the new matrix or in the shortcut that we are using is that the line that the shape was reflected along is now different. So we put our mirror on a different line. So that will require us to use a different shortcut. And this shortcut is simply multiplying the coordinates by this matrix minus 1, 0, 0, 1. So our result is minus 4, 3. Yeah. So how do we know the other shortcuts that exist that we can use? Well, lucky for you, there is a table which is easy to cram because it's only 4 cases by which you can apply this shortcut. So you've seen 2 of the cases above. The other 2 cases are when the reflection or the line of reflection is y is equal to 0. And the other case is when the line of reflection is y is equal to minus y or minus x. So these are the lines y is equal to x, and then the other one is y is equal to minus x. So those are, yeah. Otherwise, you will see that there are other cases whereby you cannot use this trick because, for example, in this case, our reflection line is on minus 2. And I kept saying matrices or matrix. This is just a vector, so you're multiplying 2, 4 with this vector and 4, 3 with this vector. It is also important for you to note that you cannot use matrices in all the cases of reflections. So in this example that we have our mirror along the line y is equal to minus 2. This is not the typical positions that you saw in the other example. So as you can see in this table, it's only 4 situations in which you can use the matrices so along these lines. And y is equal to minus 2 is not in this case. So we cannot be using the matrix multiplication. As you can see, we have 1, 3 giving us minus 5, 3. That is because it's a different situation. So the matrix formula or the matrix method is not going to be used in all scenarios. So just make sure that when you're using the matrix, that is when you have got coordinates or when you've got a reflection line across common lines that we are used to. That is the cross or the star that I'm drawing right now. The x is equal to 0, y is equal to 0, x is equal to y, or x or y is equal to minus x. Yeah. Many questions on transformation will ask you to fully describe the transformation, so do not forget to describe reflection. The transformation is a reflection along the line, and then you provide the equation of the line. So all you need is the equation of the line on which the reflection occurred, and you have to state that the transformation is a reflection along the line, and then you provide the equation. And also make sure that you do not confuse the axes that we're talking about. So the x-axis and the y-axis. So since the way that you describe the x-axis is by saying the x-axis is equal to y is equal to 0, make sure that you understand that fully and you have a way to remember that so that you are not confused about that. Because as you can see, now that we are dealing with matrices, you have to remember which vector works for what line or yeah, whatever. So you have to remember that the x-axis, which is also the line y is equal to 0, works with this vector, and then the y-axis works with this vector. So you cannot be confusing your lines by then.